Yo, what's up, everybody? Welcome back. Today we are working on my map application, and today's topic is adding satellite images to the map. So, for context, I'm making a map of Vancouver. The intent here is that I want to get around Vancouver, typically via transit, but maybe via foot, whatever, maybe by bike. And when I ask Google Maps how to get from one place to another, it gives me like routes that I really don't like. Specifically, it believes that I can't walk 4 blocks to get to a bus stop, and it also believes that I walk really slow. It also believes that buses will always be on time. It believes that I'd prefer to wait for a bus versus walking to a faster route. There's all sorts of things that it does that I don't like. So I'm like, okay, fine. We'll make our own. We can make our own. And so where we're at right now is this is like a map of Vancouver. We have street data pulled from OpenStreetMaps, and I can use a star to plan a rudimentary route. Yeah. Okay. Where we don't have any transit stuff yet, but the plan is eventually to kind of like pull in transit data and maybe like profile how consistent each bus is, and then we can use that to look for like consistent routes over fast routes or over less walking routes, whatever. We're planning on adding stuff like based off of street attributes, like here this says like it's a residential street, or here it says that it is a like somewhat busy street. Maybe we want to do things like say I don't want to walk down busy streets. Maybe we want to do things like say I don't want to walk that up like hills that have a grade that are steeper than like 3 degrees. Maybe we want to say that I don't want to walk through the downtown east side in the middle of the night. Right? There's all sorts of stuff that we can like do, and that's kind of the plan. But right now we just have a star go through graph now. Pretty good. Today's topic, though, is about adding a satellite view, because when we're like testing this stuff, if I like zoom into an area, I find it like really hard to tell where I am. And so if I'm trying to like demo something, like say like where the hell is like Granville Street, I'm like I have to like zoom out, like be like, okay, this one's Granville Street, line it up, and then zoom in and be like, okay, now we're on Granville, right? Which is kind of hard, especially like when I'm like in an area like this. I'm just like I don't know what the fuck is going on. And so I wanted to add some sort of image that like represents the world in a way that I can understand it. So I was looking into this yesterday, and it turns out this is like not super straightforward. If you like look up like satellite images, there's like these like Landsat and Sentinel-2 things that are like freely available. But if you like look at the resolution of this thing, like Landsat's like 30 meters per pixel. Right? So it's like, what the fuck is this? This is like a massive park. You can't even like see streets on here, right? It's like, what am I looking at? Sentinel-2 is a little better. It's 15 meter, but it's still not like what you expect to see when you're like on Google Maps and stuff. So I'm like, what the fuck do they use? And it turns out, as far as I can tell, that typically they kind of use like satellite imagery at really far zoom levels, and as you zoom in, then they start to use like photos taken by like drones and planes and shit. So I was looking at that, and it turns out that a lot of this stuff is kind of hard to get at too. So here, do I have an example open? Maybe if we open this in Map Viewer. Fuck. Open. No? Okay. Well, basically, like, this looks a lot more like what you'd expect. This, I swear I didn't have to log in yesterday. Oh, well, whatever. But the licenses of stuff like this is, like, pretty, restrictive. Basically, when I was Googling it, when I was like, how do, like, OpenStreetMaps get satellite view? What I could find on the internet kind of indicated that basically OpenStreetMaps for certain areas asks providers of these maps for special access for OpenStreetMaps. So if you want this like high res data, you typically have to pay. And even if I did pay, you would have like restrictive licenses that are like, you can't use this shit unless you are using it with like our software. Google Maps exports like its stuff, but again, you're not allowed to like cache the stuff. So you're like tying yourself to a live service. So fuck that, basically. But what I did find was there is in the Vancouver Open Data Portal, there is ortho imagery of all of Vancouver, which is great for me. So it looks like it's split up into these like tiles, and we're gonna try pulling some of these images and looking at them and trying to like basically staple them onto our thing here. So plan of action is approximately, let's like get one tile just displayed anywhere with webgl. Then we need to display it in the right place. Then once we do that, we probably want to like downscale it for as we zoom out, because they're very very high res images, and that's silly to keep all of that in memory for no fucking reason. If we can't like see, like if we're like this level, you can't see the cars on the streets, right? So we'll kind of just like discard that stuff. Make maybe like either you fall back on Landsat when we're really far zoomed out, or maybe we'll just like pre-bake our own LODs. Who knows? And then let's like at some point we're gonna have to like take all of Vancouver and use it. I think probably this stuff actually comes kind of like first. I had at the end because it's like getting one tile versus like getting what we believe like the correct structure of the data is kind of depends on what we do in the rest of the stream, right? So there's going to be something there, but we can probably have like an initial guess at what we think the correct data format should be. So that is the plan, and let's just jump in. Are Google Maps 3D models open? I would assume no, but I don't know. The really high satellite imagery is almost always from commercial providers. Yeah, that's what I found at the very least. Okay, so if we look at this orthophoto thing, they have this like export where I can like export the data set into some JSON. And in here, they basically have like names of the files along with like locations where I can get them in the format of Mr. SID or ECW, which are both like, I don't know why the fuck the like open Vancouver data portal is using proprietary image formats. I'm sure there's some reason, but I don't know what it is, and like it's fucking annoying. And I was like I was trying to open one of these yesterday, and it was like really struggling. But what I eventually found is that there is this Mr. SID SDK or something. So if you look up, I got here by going through image magic Mr. SID. This is how I got here. There's like, as well as like GDAL stuff. Anyways, eventually I got linked to this this like SDK page from this site that used to be called Lizard Tech, is now called Extensis. And here, if you actually go to their like developer resources, developer, I actually don't know how to get here from the main page, but basically like one level up from here, maybe it's here. Yeah, they say, shut the fuck up. I don't care about your fucking cookies. They're like, hey, we have these like SDKs to open Mr. SID files. And then they're like, do you want any files? And it's like, oh, there are none. But if you go into deprecated versions here, you find, shut the fuck up, reject. If you go in here, you do find there is a Linux 64-bit SDK that you can download. So it's a potential security risk. Fuck it, I don't care, right? We ball around here. Fuck it, we ball. And in this thing, there is a converter of Mr. SID to any other image format. So we're going to be using that. And we're just going to download one of these at first. Just to get a feel for it. Okay. So we should be able to go into our downloads, and let's like look inside. What did we download? We downloaded C10 was the tile that we downloaded. And so in C10, we have this like SID file, and we can open it with this Mr. SID SDK. So unpack this shit. And I think it's in here, raster bin Mr. SID decode is what we're looking for, if I remember correctly. I wish, part of me kind of feels like it's cheating that I did some of this off stream yesterday, but, this is my stream and I can do what I fucking want. So, live with it. But also it took me like forever to figure this out, and it would have been a boring stream. So, cannot reload dynamically linked executable. Right, so I have to Steam run this shit because on Nix OS, all of my libraries in like fucking weird spots, and then I need to say, hey, there are some libraries that come with this Mr. SID SDK, and let's get those in our search space as well. Okay, now there's no help. There is just no double dash help like every other program. There's only single dash help. According to the open source Geospatial Foundation, Mr. SID was developed under the aegis of the US government for storing fingerprints for the FBI. What the fuck? Why? And why did they call it Mr. SID? So I think its input is C10 SID, and then we say output is like C10 JPEG? Oh, unsupported color space, C10 JPEG? Unsupported color space, C10 ping? Okay, here we go. Here is something. It's taking a long ass time, probably because it's a big ass file. Here we can see some information about it. So this is probably, I don't know if the scale must be like degrees to pixels, would be my guess. Multi-resolution seamless image database. Multi-res. I wonder if that's why they do this, is because they might like store the like frame pyramid or whatever the fuck you want to call it directly in the file. I don't know. If we actually open C10, hopefully we get something that doesn't suck ass. We can also see how big is this thing. So we took an 11 megabyte file and we made 132 megs. Super cool for us. But we do see that this is like pretty damn detailed. This is actually 10,000 by 7,000 pixel image. So this is why I was talking about LODs, because like that's a lot. But we do see that we can see streets and cars, which is a big win for us. Massive win. Okay, so let's maybe just start by like, let's shrink this a little bit. Probably we don't need it to be this big. We could probably get away with like maybe even like 5% of this, and it would still be fine. You can do it with TIFFs as well, Mr. Sitter, pretty small in comparison, if I recall correctly. Okay. I was wondering if there's like some like real technical reason why you would want to do that, because I have seen when I was looking into like the Landsat data, they were talking about like I saw a lot of TIFFs around there, and that's more what I would have expected. But it is what it is, because I could open TIFF files on Linux. Big win for me. But you know, whatever. So like it's like convert C10 ping resize 10% and stick it in C10 JPEG. Because we probably also actually want, like, JPEG compression is kind of dunked on a lot, but we actually do really want that like spatial compression, because we don't actually care that much about the quality of the image. We just want it to be small. So that's a lot better. And if we exeg open C10 JPEG, is it like still usable? Yeah, that's like probably good enough for me, right? Because like, I don't need it to be like perfect. I'm just trying to get like a not shit view of the city. We could probably even go lower, to be honest, if we wanted. Try WebP. You know what? Since we're here, why the fuck not? Why the fuck not? WebP. Holy shit. WebP a quarter the size of JPEG? I didn't know that. Okay. I mean, it doesn't really matter. This is also fine. Okay, maybe we'll just start with this. Let's start here. So let's take, let's take this WebP and we'll kind of bring it over into, I pre-made a directory before stream today called SFMAP Vancouver preprocess. And oh fuck. CP downloads C10 WebP here. And in here, when I started this, I downloaded that JSON blob from here, and here they seem to tell us fuck C10. Oh, it's all one line. That's annoying. But in here, C10 is tagged with its geometry, which is nice for us. So we have like the coordinates of the corners of the image, I assume. Right, we have like coordinates long lat. I'm the 49th parallel, so yeah, longitude, latitude, and there are 5 of them because they're defining a polygon. And if I remember correctly, I looked at the first and the last point, and these are the same. So this 244770229, 24, where was I? 2477024. So these are the same. So they're basically like defining a polygon, which I hope happens to be a square or a rectangle. And that is associated with this image. So we should be able to figure out some way to like convert this into where this should be displayed on our map. We could maybe figure out its width and height in latitude longitude space, as well as its center, and then once we de-warp the map into like meters on our side, we should be able to just like kind of like take that shit and like slap it into the same spot. That's kind of what I hope. But I don't really know. But maybe we will take like an initial run at this, and maybe we'll say, probably the easiest way for me to work with this right now is probably in like Python land, would be my guess, because then I can just use like pillow and they're like included JSON lib, and the performance doesn't have to be that crazy. So let's do this. Let's make a new environment. We'll copy this build shell.nix, but then we'll just kind of nuke everything inside it. I guess we don't even need like this. We just kind of need yoink, yoinkies, and let's do like, we want Python 3, we want Python 3 packages pillow, and we want probably NumPy will be helpful. And anything else? Curl to download stuff from the internet. And I think that's probably it. It feels like this is going to be a pain because of lens distortion. No, I think that if I read these dataset things correctly, the idea of orthophoto stuff is that they pre-process this to rectify it so that it's as if it was directly from above with an orthographic camera. Where orthographic cameras they're actually really funny. Um, they're so funny looking. Uh, real life. They're really funny. Where did I see? I think I saw one of these in the puzzle video from what's his name? Stuff made here. I remember seeing this thing and like cracking the fuck up. Stuff made here puzzle. Hold on. It's worth it. It's worth it because it cracked me the fuck up. Puzzle. Okay, latest puzzle. I think somewhere in here he gets this like orthographic camera because he wants to make sure that he removes any distortion from the puzzle pieces from his camera. Oh my god, ads suck. It turns out. And it really cracked me up when I saw it. The lens is like so fucking long. I'm not gonna find it fast enough. I think that sucks. It's really funny though. They're just like these like massive fucking cameras. Anyways, orthographic cameras. This is a distraction. They basically like normally when you take a photo, you know, you have like you take a photo of like the road, right? And it looks like this because the road, or the other way around. Sorry, it gets bigger as it gets closer to you because things are closer. You look bigger than things are farther away. And essentially, what they do to make them to like make it orthographic, you want it so that like straight lines stay straight and they stay like relative to each other. So with the orthographic camera, the road actually looks like this, which is really fucking weird. And the way they do it is they have this like big ass lens, and like when the light bounces in, they basically try to correct it so that like light coming at any angle like kind of like bounces straight back, so that like, you know, you kind of come stuff coming in like this that kind of like bounces in this way. And then they just like remove perspective. It's like if you're when you start looking at things that are like really fucking far away, the effect of this like kind of decreases over like the farther away you get, and so it just makes it look like everything is really far away and then like blows it the fuck up. Anyways, I don't think that that's what they're doing here. I think they're using normal cameras, but then they have some sort of calibration procedure that basically like unwarps it. Like if you've ever used like OpenCV, there's like rectification, I think, where they have these abilities to like look at camera, like they you can calibrate these things to figure out parameters such as like lens distortion, and like with 3D reconstruction, I think you use like two cameras and their positions relative to each other and stuff. But you can basically take the original image, just kind of like pull it out and make it look like it was taken with a camera if you know how the lens looks in the camera that you used. Lens and sensor probably. Anyways, doesn't really matter. I would have guessed the unusual property of physical orthographic camera would be its width height parameter rather than the depth. I seem to remember the lens looking like really fucking long. That's what I remember, but also really fucking fat. It might have been both. I don't really remember. I should qualify everything I say with I'm making it up as I go and I don't really know. That's the theme here. That is the theme. Okay. Do they use an orthographic camera to eliminate height discrepancies in G-space data? I would assume that they use a normal camera and then post-process it. That's my assumption. But what do I know? Nothing. I just started Googling this stuff yesterday. I didn't know this existed until like 8 hours ago. Or 12 hours ago, probably more like. Man. We call main. Okay, so we are going to import JSON, probably, and we're gonna like, you know, open the data set. JSON, open it as read and as f, and then we're gonna go JSON, I think it's load f. Then we have like data set is equal to this, then we print the data set. Probably. We don't have a semicolon in this language, and we shouldn't semicolon in this language, it's kind of habit. Okay, so that is process getting the data set. We're just gonna say, give me the first fucking thing, please. Give me the first thing. Chillin'. And we are going to maybe how do you loop in this language for data set? Dude, my poor brain. I actually can't remember. For item in dataset. There we go. That's probably it. Break once, and then we print item. We do have semicolons in Python. Oh, I didn't know. I didn't know. Okay. Then now we have like item name is where we're gonna save it. Out name. Then we are going to pull it from Mr. Sid URL. So data URL is item Mr. Sid URL, right? Mr. Sid URL, yep. And I guess we will like look at our current working directory. So from pathlib, import path, and then we have like a path dot, I guess. Current working directory is this. I guess we don't need to current working directory in this. We can just say path out name. And we can say if this exists, if it does not exist, we will download it. So we'll do like I don't want to figure out like Python HTTP. So subprocess run curl -o URL out name from URL. Check equals true. We import subprocess. I hate that I have to look up loose return because I never remember which way it works in a given language. And there's always at least one language where you can't declare your iterator while initializing a for loop. Yeah. Yeah, that's fair. That's fair. It's a hard life. It's a hard life. And then we break because we only want to do one iteration of the loop. And if we run this now, it should download this guy. Okay, and now we have B10, which is not great. We actually kind of want this to be outname joined with .zip, because I believe it comes from a .zip. So this is actually going to be, maybe we'll do this here. We'll do like this .zip and then format with item name, I guess. That feels like the way I want to write this out. Item name. I guess we'll say zip path is this from, yeah, that's fine. That's fine. Zip path. Yep. Then we have to, if the zip path doesn't exist, and then if the path item name doesn't exist, then we have to extract the thing. So subprocess run, because I don't want to look up other docs on zip path. Easy. This is how you write code, guys. This is how we do it. So it downloads. Oh wait, hold on. He's gonna get mad because of a couple things. This is actually gonna get corrupted as well. If we like interrupt this while it's downloading something, we will corrupt our zips and it will never recover because we are shit. we should maybe download to a temporary spot and then rename, but shut the fuck up. Unzip help. How do we unzip into a directory? Directories. D. So I want -d into item name. Let's try again. Baby. Much better. Much better. The art of raw dogging. Yeah, we're not coding well. We are coding. And then we want to run we want to convert that thing into a image that we can interact with. And then I was going to use Pillow to like open the image and then NumPy to like shuffle the stuff around and resize it. But I guess we can just use image magic. If we're doing this thing where we're just running fucking programs, then fuck it, you know? We might as well just go all the fuck in. So this is gonna be, I guess we'll want like a JPEG path. Is gonna be like the item name folder into item name dot JPEG. No, we said WebP is what we wanted. Before we decide that though, I want to see if STB image supports WebP because I know that that's where I'm going to be ending up using this thing later. So we might as well be certain. No. No? That's surprising. I kind of assumed that it would. Okay. Let's just, well, is there like a WebP-C library? Let's just kind of see what's out there. What's out there? Are you F because my stream crashed or because the thing isn't available? There's like libwebp. Is there like a zig libwebp? Like, I know that usually I don't do this, but I just kind of want to see if somebody's already done it or not. Because if I want to compile this thing to WebAssembly, then I need to like basically run their, we have to like kind of like rip out their build system and replace it with ours. It's kind of a pain in the ass. Pain in the ass. Okay, we're just gonna use JPEGs for now. There is a good chance that we change that later, but JPEGs is just gonna give us an easier place to start from, so it's fine. It is fine. And then so if this is gonna be a JPEG path, if not a JPEG path exists, then we run. Mr. Sid decode, I think it was called. We'll just kind of yoinkies this shit. I guess we kind of do this. Like this, subprocess run, and then we're just gonna have to kind of figure out our path setup on our own. Check equals true. There's an E in JPEG. There doesn't have to be. I don't want there to be an E in JPEG. Fuck that noise. Then this is going to be the Mr. Sid path, which we don't have right now, and this is going to be the JPEG path. So Mr. Sid path is the same thing, but Sid. Without the E, we compress it more. Yeah, genius. How did the route planning go, by the way? It like is okay. I mean, it's not great. There's still a lot more work to do, but I mean, it does something. Like, yeah, okay. So, okay. Then we need to resize it. So we'll call this a JPEG small path is 10p. We'll call it 10 for 10%. And then we'll say JPEG small path. Boom. He runs convert dash I this. What was it? Convert. No dash I, then dash resize. So this is a JPEG path. Dash resize 10%. And then was it dash O? No, it's just the output. JPEG is small path now. Okay. He's probably mad because Mr. Sid doesn't exist. So here we need to kind of like Steam run with all of this shit and then export our path is path : home streamer downloads Mr. Sid SDK raster SDK bin. And then we should be able to Steam run test.py. And I think that should fix a bunch of stuff. Python 3 probably. Still no good, because he can't find the shared libraries, because this is not in the right spot relative to us anymore. So this is home downloads, home streamer downloads. Still no. Oh, because we couldn't do JPEGs. I'm just remembering now. Steam run what? So on NixOS, all of the libraries are in like fucked up spots. So if you want to like download some precompiled binary and run it so that it can like load the shared object loader at like /lib ld x86.so or whatever, you need to like construct an environment where all of the files are in the normal spots. So Steam run is kind of like a shortcut way to say like programs in Steam are binary, so they have to provide this, and so we just like abuse that for our usage. Which is fine. So I forgot that it was not letting us do JPEGs directly. So here we'll do pung path. And let's try again. JPEG path is not fine. Do I mean pung path? I really did mean pung path. He's on to me. He's on to me. Okay. Okay. We are making a PNG, and then it should automatically make a JPEG, which means that we should be in a spot now where we can all we have to do now is like write out the metadata that goes with it, I think. So like the center, probably we want to like take the first 4 points from the geometry tag, average out their x's and y's, and then call it the center. No such file converts, so we need image magic as well. Exit. Is it image magic? Yeah. Image magic. Image magic. With a very hard CK at the end. Okay. Are we happy? We did it, guys. We have a fucking image. So now, let's kind of make it that we're going to say that our like output JSON, we're gonna like write out some like in our own format what we want this stuff to be. So we're gonna have like for each element, I guess it's gonna be like center, width, height, and image is what we're gonna export per thing. Why Nix shell? It's not like you were going to be typing it wrong. Oh, because I control C. Probably because I didn't want it. I don't remember. Oh, because I didn't. I wanted to add it to the shell.nix, not actually use it directly. Teach. Wow, look at you guys coming in here and helping me out. So, for those of you who are just getting here, hello, welcome. I hope you had fun over at Teach's channel. We are working on this map. So the idea is that Google Maps pisses me off. I'm making like a little path planner here. So there's like a red line here that tells me how to get from one spot to another. We're going to add all sorts of configuration to this thing, but we haven't done that yet. Right now, we are trying to basically add some satellite imagery to this stuff. So we've kind of yoinked Vancouver's open data portal has these like orthographic images taken around the city. And so we're going to like shove those into the background. So right now we're doing a little bit of preprocessing in Python, which we'll move into some like loading of the data in a WebAssembly Zig module. Did you prove the pathfinding last time it was taking you through Parse? I think that I'm okay with it taking me through Parse, but we will eventually add traits of tags that we want to like adjust cost for. So we could say like multiply the distance by 2 as you're walking through forests if you don't want, or if you're walking down like main streets and stuff. If you're curious, we were working on a way to configure Neonym via CSS. KEKW, that's pretty funny. Yeah, I poked my head in there like a couple hours ago, and it was like, damn, that's kind of funny. That's kind of funny. Okay, so the last piece here is that we have an extracted image. For those of you who are coming in here, let's kind of show the image that we're working with. XGG open. Dude, that looks so fucked. But I guess this is the beach. This must be the ocean here, and this is like trees along the coastline. So this is like not the greatest example, but you can see that we can see stuff in a park. Oh, I actually know where this is, I think. No, I lied. I don't know where this is. But that is an image, and we will figure it out. We'll figure it out. The perspective looks like it's jumping on the picture. I think it's probably just because we happen to pick like one of these guys over in the top left. We must have picked like this one here, and that's probably shit. So maybe it's fine. It's fine. It's fine. Who cares? Who cares? Maybe we will. Yeah, it's fine. It's fine. Okay. So we have an image, and now we just want to write out where it is. So here, I guess we'll have like var output. No, no var, just output in this language, and we'll output dot push append push. I don't know what it is in this language. We'll find out real quick. And it will be a little dictionary that has center of some like x and y, which we don't have yet. Then it will have size, which will have width and height, and path, and who will show in the full path. So the full path is easy. This is JPEG small path, and we want to convert this to an absolute. So we'll say path dot resolve, and then I think we have to string this shit again, something like this. I don't know. We'll see in a second. It's actually pushed back. I know it's not pushed back. That's C++ if I've ever seen it. Okay, then we need to calculate the center. So I think it's like in the metadata for the dataset, it's like item geometry, I think we saw. From 0 to 4. That's not how you do this in this language. I don't know. 0 colon 4 gives me a slice, maybe? I don't fucking remember. There's a lot of stuff that's just like fucking broken here. Pass. Unhashable type slice. Okay, does item geom work? That's fine. Oh, and then we want coordinates. Actually, let's actually throw it back. You got me. You got me. Okay. So then here, coordinates is wrong. Was that not it? Geometry. Oh, geometry. Geometry coordinates. Of course. Of course. There we go. So coordinates. Yep. We're getting there. We're getting there. It's from 0 to 4. No. 0 to 4. Jesus Christ. That looks right. 0, 1, 2, 3. That looks right. That looks right. Because I think if I don't do this 0 to 4, it'll give me 5 things because it needs to close the polygon. 0, 1, 2, 3, 4. Yeah. Chill in. I could have sworn it was Hawk Tua. That's pretty funny. I know I just merged two people's comments, but I get to choose what I pretend people said on the stream because it's my stream, and you guys can't stop me. So get fucked. You know. Okay. So this is chords. So for chord in chords, we are going to say var or lons is equal to 0. Lats is equal to 0, and then we say lons plus equals chord 0, and lats is plus equal to chord 1. And then at the end, we say lons center is lons over 4 and lats over 4. Boom. Size is we have to keep the min and max. So is a math dot inf maybe min lon min lat, then max lon max lat get the negative versions, then max min lon is equal to the minimum math.min. I should fucking install a language server, but we're too fucking cool for that. You know, because I don't want to go open up my shell again. So, you know, we're fucked. It does look like that didn't crash, so we're on the right track. Then we replace min with max. Resist, I coded that autocomplete too. It sucks, man. It's not because I wanted to, it's just because I forgot to. Min lat twice. That's a good point. Is this Nick's? Getting LSP sucks? Well, now that you've said that, I have to prove you wrong. This is the classic, if you're on the internet, you just say something that is, incorrect and you get your answer. But you just type pi right here. And then I think it's fine. I also code with syntax highlighting. You're nuts. You're a crazy person. Could your software be deployed on a terminal? I don't know what that means. Which software? My map? How would you look at it? What is it like by a terminal? Do you mean a terminal emulator? Debate into getting LSP. Yeah, you fucked me. You really fucked me there. You win. I lose. Okay. So append. Everybody who said it's push, fuck yourselves. By the way. Like, so center is size is. I guess we don't need to store all of the lawns and lats then, huh? Because we kind of know the center. We don't want to average them. We just want like width is max lawn minus min lawn. And yes, maps. Okay, now you need to explain what you meant by deployed on a terminal. I have no idea what that fucking means. Only a little offense attended, not a lot of offense. Like playful levels of offense, you know? So this is width height, and this is gonna be min lat lawn plus width over 2. And this is min lat plus height over 2. Okay. And then here we should just be able to like f JSON write print dump into, which way does it go? Obj first on the file pointer. Wow, guys, language servers pretty fucking nice. Okay. That looks like exactly what I want. Exactly what I want. So this is the size in latitude, longitude, in x and y in coordinate space. This is the center in coordinate space. I think we're chilling. I think we're chilling. So now, all of that to say, we now have a tile that we can work with. And so, let's do something with it. Looks like a cool project. Does it support Bash? Use the app through the terminal. I mean, I still don't know what that means. What are you trying to do? Maybe like use like full sentences and paragraphs. Like I assume I'm getting a picture that you're asking. I want to plan a path from one place to another by throwing coordinates on the command line. Maybe. I mean, you could. We have like we can compile the app to do whatever we want. We have a path planner. We have map data. Interfaces like we have an OpenGL native app right now and a WebGL app, but like I don't know, we have like a benchmark program where you can like run the path planner, but it won't like print anything useful. You'd have to like, would you want to like display, like are you asking me like would you want to display it in ASCII in the terminal? The map would look like shit. But like I guess like there's not a reason that's not possible. We did at some point write a image to text thing that we could like run it through. I just think it would look bad. Mapski is a thing. Yeah, okay. I just can't imagine it would look. I guess like probably instead of doing like what I did, which was like look at the pixel values and try to like pick a character that is like the most like brightness related, you could maybe do something like try to edge detect the roads and then draw them with like different characters. I don't know how many angles of lines you can draw on the terminal though, but I imagine it's not a lot, and you would have to know like the character width and height, which I think is gettable through end curses, but yeah, I'm not sure. Not sure. Sounds like a lot of work. Actually, you could draw with Kitty Graphics Protocol. Is Kitty Graphics different than Sixel? Because I did want to get it. I did want to check out Sixel at some point. Yes, it's different. Probably just raw better, right? Much better. Yeah, makes sense. Sixel's pretty limited. Okay, what was I doing? I was gonna open the file. Open the file. So let's just start with only the wasm version because I don't really want to deal with everything else right now. So let's add a build step here because this has been pissing me off. So we'll call this like wasm step is a std build step. And the only thing that we will add to the wasm step is building app. So self wasm step depend on why I'm not in the right next shell, so there's no autocomplete here. Fuck. We'll get there though. It defeats the person who's using a phone to view map. I will be using my phone to view the map. Wow, the pool table looks so awesome and works great. Whoever made it. Yeah, dude. Whoever, like, I can't remember his name. DE. I should make it so that I can hover over these and see it. But yeah, props to this guy. This is the coolest one by far. This is so fucking sick. So sick. If they're in chat, you could pipe up and say, it was me. But if not, I'm sorry for not doing you justice. Okay. We were editing the build zig so that we could build only the wasm stuff and ignore the compile failures of everything else. So I think it's like wasm step. I think it's just this. I probably want like the install target. So this should return whatever the fuck this is. So we want like a add install artifact. So this is the const install artifact is this, which returns whatever the fuck this is. It's a step install artifact. Build step install artifact. Then we depend on the install artifact.step for the normal shit. This comes from which one of these is not? It's the original that we get elem here. And then here, when we install and check on this guy, we depend on the installed here. There we go. So now when we run build wasm, it should only create the wasm object and put it in the right spot. Here we have to discard the return of this thing for everyone else because we don't care about it. Isn't the vacuum supposed to suck the balls? Well, okay, so we had a shop vac growing up, and we use it as a leap filler. So he's not really doing... Sucking the balls into the hose was going to be more work. So we just stopped at pushing because that was funnier and good enough. I think that like things doing a bad job is almost better than things doing a good job a lot of the time. To be honest. Wasm step, I guess we call this, and then here we'll make the wasm step. Wasm step is wasm. So I hope now that if I call zig build wasm, it only builds one executable. So if we go into like arm-char zig out and then we zig build wasm, we should just see only the one thing. Perfect. That's exactly what I wanted. So now I can like fuck everything else up and it won't bother me because it won't affect me. And we all know that if you close your eyes and plug your ears, the problem doesn't exist. So I guess in index JavaScript, we are probably going to try to like get some metadata for satellite data. So we're gonna do like await load satellite data. And let me think about this. So this is kind of gonna go, the flow is gonna be like get metadata, figure out where we are, figure out where tiles are, request tiles to be loaded. So the question of like who owns which side of this is like a little bit we can choose how we want to represent this. I think what I want to do is JavaScript loads metadata. Metadata of what? Which tiles belong in which spots, right? So right now, what we just finished processing, which I guess you're right, I did not really explain at all, was like we have this like image, right? And we have like a tile here in the image, and a tile here in the image, and a tile here in the image, and these are each like defined as like center, width, height, plus image file. So we can choose like who displays this stuff. Now, pushing more into the zig side of the code is nice because we get more automatic reuse. And we are going to probably render these things as textures in OpenGL. We could stick them onto the canvas manually from JavaScript, but I think it'll just kind of, everything will play nicer, like with like zoom levels and stuff, if we load them as textures in OpenGL. So I think that what I want to do is like JavaScript owns like the knowledge of who lives where as well as their paths. He will like JS tells app where tiles are, then app decides when to load. So he'll be like, this is in view, I need to like make a texture that's associated with this thing. And then app will ask, what about scaling the tiles when zooming in and out? So if you're talking about like changing which tiles, I think that will be owned by, we'll probably like set the LODs in JSON owned by JavaScript. Probably we'll like tell the app about, maybe we just pass the metadata over to all the way over to Zigland. That might end up making more sense. We'll see in a second. Eventually the app needs to ask JavaScript to load image into texture. We could do this into two steps where we ask JavaScript to load give us the file data, and then we load the image into texture when it's complete. This might make more sense because it would allow us to kind of do some amount of like processing of the thing in Zigland. Yeah, let's do it that way. Let's do this. So we say, in which case, like if this is all owned by like Zig side, then it kind of makes sense for app to own the metadata as well. Owns file, owns like tile metadata. So then all JavaScript has to do is provide like a GL gen textures, GL bind textures or whatever, and like GL texture data. I don't remember what all of this is, but it's something along those lines where we like generate a texture, we bind the texture, and then we shove some data into the texture. And then JS will, on initialization, like fetch metadata from server and feed to app on init. Yeah. Or before init. Sure. That seems reasonable to me. Load satellite metadata, we'll call it. Metadata. So we can kind of copy the other loaders. So we load some data from the server. The thing we want to get is like satellite data JSON. We feed it into our WebAssembly module, and we're going to call this like push satellite data, which means our index.zig needs a function called push satellite data, which exists. We can just copy paste one of the other ones. So it's going to be push satellite data. He takes in a length because the way that this works is this like load data function from the JavaScript side. He basically says like, hey, I have a buffer, like a global 16K chunk available in WebAssembly memory. I'm going to like get 16K worth of data, shove it into that chunk, and then push that data into some global memory in like Zig side. So Zig says like, okay, I know I don't need you to pass in the buffer because I know that you're giving me buffer through this like global chunk. And so all I need to do is like push the correct amount of data into like my storage for this concept. So we'll call this a satellite metadata buff, which means that we need to make one of those, which is simple. Satellite metadata buff. Chillin'. So there's a piece missing here where like this satellite data, where'd it go? Satellite data JSON. I can't remember if I answered someone saying, what about scaling the tiles and zooming in and out? But I think that'll come for free with our texture mapping in WebGL, on the WebGL side, I think. We'll have to figure it out. We will have to figure it out. But I'm pretty sure that we can like draw like one big quad behind the thing in the whatever texture space, and it like the coordinate mapping should just kind of figure itself out. But we'll see. Okay, so the piece missing here is that like we are now expecting that the server has this satellite data thing, that it might not have. So when we have this like make site thing that like basically like takes OpenStreetMaps data, pre-processes it, and then spits out like a folder that has the correct structure with symlinks to the correct spots. And so we can probably just add an argument to this thing. I think this is probably where it like belongs. And we'll just say like one of the many things that we need from you now is this like satellite data. And I think that will support the satellite data being empty. And if it's empty, we'll just like have no tiles to use, and that will be fine. That will be fine. So here we say if we have a satellite data who starts as maybe an empty array, but if we see the words satellite data, then all of a sudden this becomes this or else panic, and we'll say no satellite arg. Good enough for me. And then here we get, say, satellite data is equal to satellite data. Cool. Cool. So that means that over here then, at the end of our whole shebang, I think we just say if, well, like SEFS, current working directory, open file. We don't usually open it. Is there like a, exists? Read file, copy file, stat? Is like stat what I want to do? Maybe? Zig, check if a file exists. Access. Sure. They're writing with exclusive, which isn't really what we want. Okay, sure. So access the subpath of args satellite data. Why am I doing this? This is stupid. This isn't what I want. I want if arg satellite data len is greater than 0. That's what I want. This is the condition where we actually fucking do something. So if it's equal to 0, I guess, we will just kind of like stub out some data there. So maybe here we like look at like source satellite, we'll call it like image metadata. I guess it doesn't really make sense to call it satellite data, but we've already kind of started that naming scheme, so fuck it. Really, it could be any images. Nobody's guaranteeing that it has to be satellite. And it's not satellite. We're kind of just lying all over the fucking place, as one does. And what do we decide the format was going to be? We have center. Never looked into Zig. It's a comfy looks like a comfy language. It's pretty fun. I'm a fan. I am a fan for sure. It feels very, very like it has like the simplicity of C, with like some niceties on top, and it just feels like it like lets me do what I want. You know, it's like a little safer as well, but for the most part, it's not too bad. Like it's like safer than C. It has like some of the safety that Rust provides. They have like a pretty good, I think, like the concept of what do they call it? Like undefined but checkable behavior or something, what they call it, like out of bounds accesses. They go like, look, if you want to like fucking forgo our safety checks, fucking go for it, but if you want, we can check that stuff for you. And that's like a kind of nice balance, I think, is like you go like, I know for sure that like this indexing is fine, don't fucking check it for me, I'll just compile with release fast, like it's fine, I care about the performance more than the safety. And they just like let you make that trade-off, which is very nice coming from Rust. So we have a bunch of items, and our thing, I guess we need to not make this like a raw struct. We just want this to be like image satellite data.zig in lowercase. And here we'll call this an item. And then here we'll call this satellite data is an array of items. And then when we make our site, we will just, I mean, we know that this is like a fucking empty array, so we should just write out We don't even need to go through like the JSON parser or anything like this. We can just say like std fs current working directory create file of arg satellite data. No, we need the name of this thing, which we don't have. So it's not arg satellite data here. It's output. Arg output. Are the tiles you downloaded to fix scale? I mean, like in Google Maps, they scale the tiles to be more granular as you zoom in and vice versa when you zoom out. We have high res info, and we could just kind of like make LODs as we want. So we will choose to. We will probably end up having in this metadata like a layer ID or something, like a size ID, and like then we'll like tie each tile to which size we think is appropriate. But that's a problem for future me, not current me, because that would be too much probably for this stream. I don't think that we would finish in 2 hours if we tried to do all that stuff. So we might not finish in 2 hours now because I'm spending time talking instead of working. So it is arg's output, and we want to join the output path to something else, which I'm sure we've done something somewhere else here. I think it's like std fs path join. This is exactly what I want. So here we say the output satellite data path is this with satellite data JSON. We free this shit later. And then here, if we don't have anything to put in there, we just open the satellite data path. In fact, we probably, I guess we will be symlinking in the other case. So here is the only case where we open it with I don't give a fuck arguments. This has to be satellite F probably. And he doesn't like this probably because I have to try this. Then we just like satellite F write all an empty array. Chillin'. And then in this case, where we have the thing, we just symlink it, which I think we have like, we've linked stuff before, so it's just link file in out. So we can just call that, that's fine. Link file, given allocator. This isn't quite what we want actually, because he's assuming that the name's gonna stay the same and we're not assuming that. So we'll copy paste the insides. Fuck it. So the symlink from the input path, which is arg's satellite data, to the output path, which is we're gonna like look at like current working directory, and we're gonna symlink relative to our current working directory to arg's to satellite data path like this, and that's fine. I think that's it. Tries for noobs. I mean, there's some nice things about not repeating yourself, but there's also some annoying things about not repeating yourself. I think it's like, as with all things, there's a nice little balance that you need. Okay, so let's make our site with the shitty data, just to kind of see if it runs correctly. Hopefully it does. Hopefully it runs right. We gotta give him a sec because we're building in release mode for some fucking reason. And we should see that here he made an empty array, which is great for us. And then if we provide satellite data is maps Vancouver preprocess output, path already exists, so we need to fix that. Does this just allow overwrite? No. So we have to say, so this probably has to have like truncate equals true on it, so that if we don't pass it, this works. Yeah, we got the IP. It's this latitude, longitude. You're a genius. You're a genius. Okay, so that works. No crashy. And then here we just need to say, if the file exists, we like delete it. Delete file in output path. Fine. If that's what we gotta do, that's what we gotta do. This man has backup IPs. It's so fucking stupid. So now, instead, I expected this to be a symlink, but it's not because we didn't actually pass the satellite data is maps Vancouver output. So now this links, but it links shittily. So broken link because he's not resolving correctly. I see. So that's what this link path is for. So we have this like input thing, we link by name. So we just want to do like this. So here we get a relative path given the output dir. So the output directory is this a path? Yeah, so this is going to be like fs. What the fuck am I missing? There's something really fucking stupid going on here. We need like relative path goes from to 2, and if they each resolve from the same file. Oh, okay, sure, that's fine. So this is args output resolving to args satellite data. Defer alloc free link path. And then here, instead of using the args path, we use the link path. That should do it. So that should fix the fact that it needs to know where it is relative to its output. This is how the crumble cookies and this is how the turntables. There's something so funny about like mispronouncing like common phrases. I was laughing so hard at myself the other day because I just think I'm really funny, so I just say things and giggle to myself. But I was talking to my friend, and I said 3 corn on the cob instead of 3 peas in a pod, and I don't know, it really fucking cracked me up. It's just funny being like so close but so far. Okay, so now we finally have satellite data. Chillin'. So what's the next thing we wanted to do? We want to look at that data. So in index.js, we feed that data. We already feed that data in, I think. Load satellite metadata. It's not green, which makes me think I didn't type it right. It's because I called it load metadata again. Of course I did. Now it's green. That's a big win for us. And zig build wasm, and well, let's log on initialization what we get there. So in index zig, we can go to our init function and we can say like, actually we can even try to fucking parse it. Why not? Parse satellite, and this is gonna be like a global parse satellite metadata is the parsed satellite value, and then here we say const satellite metadata is equal to import satellite data.zig .satellite data. Okay. And then here we parse that thing. We need to store this thing in global space so that it's not referencing some sort of like you know, stack memory when we pass it in, but that's fine for now. And then we just like std debug, no, log debug anything, and let's just like see what the fuck we get, which is the parsed satellite value. Yes, and this should say satellite data, and this should come from the satellite data buff. Sure. AI will replace us. Cool, man. Super cool. So big build wasm and python -m http server. He doesn't like this because something. So this can't be predefined like this, so we just kind of like give him an empty vector for now. No field name satellite metadata because I called it something else. Metadata. Okay, so now when we load this, we should see in the console unreachable execute. That's not good. Oh, that's okay. That was left over from before. So we're actually good here. We do see our satellite data. He's been parsed correctly, which is really good for us. Really good for us. So we are getting somewhere for sure. We're getting somewhere for sure. Now, what's next? I'm thinking. We have to think. I guess we now need to ask JavaScript for that file data. That's what we said the next step was. So here, let's kind of just say that in here we pass in the global satellite metadata. This kind of goes in here, and so our app init now needs the satellite data. Metadata, which comes from a const satellite data, which is again not satellite data, but we lie around here and it's our thing. Import satellite data, and we have dot satellite data. Okay. Now the question is, what the fuck do we do with this? I'm thinking. I guess we kind of pass for now. For now, let's just get the data and like inject it into our renderer. So our renderer is gonna have to have some sort of like mapping of textures to positions. So how are we gonna draw this in OpenGL land? Probably we will render a quad at the location specified by the texture, and then we'll bind the texture to it. So we're gonna need like some vertex shader that takes in some. We can probably get away with like not even making like a vertex buffer for this, because the vertexes for the quad are just gonna be like hard defined as like the four corners, right? And all we have to do is just hard code those into vertex shader. Okay, let's start by drawing a black box, right? That's simple. We'll just draw a black box in the renderer, and then we'll figure out the rest in there. Maybe we'll make it like a yellow box or something just to get crazy. I like that. Okay. So let's go into our renderer and just kind of figure out what that looks like. So I think we're going to need a new shader program. I think that's going to make sense. So where's our like vertex GLSL? Okay, this is source. We'll call this like rect GLSL. And I know that there's a way to like use like GL position to get the like vertex index and then just hard code those things in there. So I think I've seen some like maybe like glow Rust examples is where I'm thinking right now. Like hello source main. Here we go. So I think I've seen it in here. Yeah. So they hard code the vertices in the vertex shader. So they just have a const verts is this shit, and then they use GL vertex ID to index into it. Okay. So we are going to have. I guess we should start by copying an existing vertex shaders that we have all the like fucking bullshit set up. What are our like parameters to this thing? We're gonna give it like the center, which we have here, lat center and lon center. Zoom level feels appropriate. I'm thinking, wait, one sec, we're thinking. So we need to convert into like clip space. Let's kind of just work slowly here. We'll work slowly. So we're not gonna handle any of this stuff right now. We are just going to draw the thing. So we're going to take this. We're going to say, hey, we have some vertices. We have some fucking vertices, man. And we want 4 of them. And they're going to go from negative 1.0, negative 1.0. We want to draw, we need to make sure we get the order of this right. We want to draw like this triangle, then this triangle. So the last one will make 1, 1. The first one will make negative 1, negative 1. So negative 1, 1 goes to 1, negative 1 goes to dude, my poor little stupid fucking brain. It goes to negative 1, 1. It's 1, 1. Okay. Then we index into this thing with this. So this is GL position is equal, GL position XY is equal to this, I think. Is this how you do this? Maybe we do, maybe we'll do this. We'll do GL position is equal to a 4D vec using X, and we'll say like const vec2 vert is equal to this, and then we can say vert.x, vert.y, 0, 1, because we're using homogeneous coordinates, where the fourth dimension is kind of like a scalar for the other three. So if this is like less than 1, all of these things get smaller. They do that for like math reasons. It took me a long time to figure out one time at work, and then I've just never really thought about it again. And that's kind of it. No inputs. Just run the fucking program. You can just do vec4 vert 0, 1. Oh, really? It's smart enough to like handle the like XY shit? That's kind of nice. I'll do it. That sounds nice to me. Verts GL vertex ID. Okay. And then we're going to want, what's our like fragment shader look like? Our fragment shader just takes RGB values in, so we can like kind of reuse our existing fragment shader and just tie it to this vertex shader for now, and then eventually we're gonna have to make one that like we are blind to texture to, but we're not doing that yet because we are a fucking lazy piece of shit. But more importantly, we like to see incremental progress because our stupid fucking monkey brains can't handle not seeing incremental progress for a short period of time. So when we initialize our renderer, we are now going to compile and link our we'll call it like texture program. And he's not going to use VS source, but he's going to use, where the fuck is this defined? Rect source. And this is rect GLSL. Okay, then this stuff is going to have to get stored somewhere. So we write them down. Program is equal to texture program. And then on render, maybe we will just kind of bind that thing. The way this is set up is kind of fucked. Sorry, I'm thinking. Okay, for now, we're just going to do it here, even though I don't think it's fine. Will this work in either 4 vertices or 6 indices for 6 vertices for a quad? No, right? I think you need, you can draw a triangle strip and it'll be fine. Texture program. So for now, I'm just going to do it here. This is not the right spot for this, but I just want to see somewhere. So it should be like self dot, no, it's GUI. GL bind buffer, bind, do we never bind the program? Use program. That's what I look for. So we use the program, then we run it. We're getting crazy here. So there's something kind of fucked here where it kind of feels like I need to get the uniforms for that thing. Right? So I need to know where the R, G, and B parameters are. So it's almost like all of the stuff that exists in our current renderer is kind of like assuming that it's for a given program. So there's something kind of odd here where like the abstraction doesn't work right. But we are going to come back to that later. So we'll kind of just, so texture R is a float uniform. We'll just kind of do this. Texture RGB is like this. And then here we will do this same thing. Float uniform.init. What does this do? He get uniform look for that program. So we don't have to bind the program to get these, which is good. Who made that song where the dude sings, "I'm waking up, I feel it in my bones"? Whoever said Imagine Dragons I think is right. I feel it in my bones. I think that's what you're thinking about, and I think that is. No, you know, fell for it. Fuck. Imagine dragging these nuts across your face. That's so fucking stupid. That's so stupid. I'm just gonna time you out for that one. That one, we're not doing that. we're not. That's. I know it's a harsh response, but we need to set a precedent. We need to set a precedent. Turn music on, please. No music for main course time. Only text. Only music in happy hour. Okay. Texture R is a little texture R. GB. I'm the captain now type of situation. Yeah, it's like I can do what I want, right? If you, it might mean that you won't like me anymore. But oh well. These all need U's here. Texture. Okay, I would, if I answer this question and you do the same thing, you're getting timed out too, right? Have you heard of the Illides? No. Okay, well, it's the oldest decent. Okay, well, bye. We got another one. He wants out. He's asking to be sent to jail. They thought you're too nice for answering, and they saw how cruel you can be. I mean, it's not that cruel. I didn't ban them, which is kind of a, we have some empathy here because they don't know the rules. I mean, he did know the rules. I should have banned the second guy. Actually, I should. Okay, what are we doing here? We have some parameters that we can set now on our program. For our brothers who took the ban for us. Yeah, we should all pay respects. Can I get some 07s in the chat, please? We need to salute our fallen comrades. How did you fix a spelling mistake for the next two line? It was Control V does a vertical selection, and then I did like X after a Control V to delete everything in that column, and then I did another vertical selection with I to insert before it. If you're a Vim guy. If you're not a Vim guy, get fucked. So somewhere we are supposed to bind. We were adjusting our render function. We were using this program, and then we could say like, self renderer texture R set to 0. We'll do G and B as well, and let's just render like a big ass green thing over the whole screen. If this is working, then we're chilling. And then we can say like GL draw arrays, and we want to draw a GL renderer, GL triangle strip, which you don't have defined yet, but we will. Triangle strip, and we're drawing 4 points. So that should do it. For those learning, X plus I can often be replaced by C or S, and you don't have to visually select again. That's true. If I'd selected 2 columns and then replaced it, that would have been better, maybe. Okay, we need to define this triangle strip thing. So we will go to this webpage and copy paste it out. Triangle strip. This is how you write code, guys. You just copy paste from the internet your constants instead of importing from some library. Imagine trying to use a library instead of just randomly copy pasting stuff. Okay, so this should be good. Should be good. I think that if we did everything right, on our first load, we should see just a giant fucking green blob if I refresh here. And we don't, because vertex fetch requires 4, but attributes only supply 1. Ooh. So does this not... even though I'm drawing directly from like vertex, like shader memory, does he not allow that? That's kind of annoying. It bothers me so much that you didn't order them by value. Yeah, I know. I saw it and I was like, fuck it, I don't really care. But I can see the pain for sure. So I was under the impression that this was fine. WebGL draw arrays. Can I like do this? The problem with GL draw is expected more vertex value than received. missing data because my call to buffer data was failing. Sure, I mean, I understand that. But do I need like webgl draw arrays vertex without buffer data? Like I don't really understand. Without data, drawing without data. So traditionally, blah blah blah. I'm assuming in here he does one components per iteration, move forward 0, 0. So stride 0. Ah. So by doing stride 0 and offset 0, it might make it so that I can say however many I want. That's kind of interesting. So I still have to call vertex attrib pointer. I just have to get a little crazy with it. That seems fine. We'll see if that works. So here, I guess that means that we need like a vertex attribute object associated with this program. So we'll just kind of shove a like texture val in here, which is a little annoying, but fine, whatever. Here we'll say that the texture val is something that we upload with 0 points. Does this make sense? GL vertex attrib pointer. So this takes in location, size, type, normalize, stride, offset. Why is my stride ever 0 here? This feels fucking wrong to me. The fact that my existing code works is now confusing to me. To be honest, this may just not be what I want. He gets a circle of points here by doing this. So what has he done here? He's created a vertex shader that has no... Oh, he just takes in the vertex ID manually. Oh, maybe the vertex ID doesn't exist here. So he actually makes an ID buffer with the vertices in it. Which is like fair, I guess. Vertex IDs, yeah, he does do that. It could be, that wouldn't shock me actually if the vertex ID thing doesn't exist in whatever version of WebGL we're using. There's like GL, oopsies, GL vertex ID WebGL. Is this like not allowed? The index of the vertex, blah, blah, blah. When using non-index rendering is the effective index of the current vector. May I assume? Blah, 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 blah. Yes, it is always going to be the logical index of the respective vertex and sequence. I don't really understand. GL vertex ID, WebGL, buffer data. Like, I feel like I'm missing something. So it feels like this should work. In Glow, do they do something special here? They use program, and they just call draw arrays. They do just call draw arrays, which I feel like should work. So I'm missing something fucking obvious here, and I just don't know what it is. Why? Because that's all I'm calling here, I think, is GL draw arrays in appsig. Draw arrays, yeah. I'm missing something because they don't do any vertex attribute binding here, right? Vertex. Ooh, wait, they do make a vertex array. And then they bind it. But they don't do anything with it? They create the shader, they compile it, they get the link status. I wonder if we have to do that? and we just like don't do anything with it? That's like possible. We could try doing that. So they just create it and then do nothing. And then here we can like bind that vow. Fair enough for the timeout. Respect you for it, 07. Oh, he's back! He's back, baby! Wow, that actually wasn't actually that. I expected it to be longer, to be honest. But it's not the end of the world. Okay. GUI GL bind vertex array, and then it's self renderer texture vow. I wonder if this changes anything. I don't think it will, but it could be that it was like trying to use the vertex array object associated with the other data, but I just don't think it should matter. Now it's not complaining about anything, which is actually an improvement, but it's also not doing what I expected, where it's not drawing jack shit. Now the question is why? Let's think. So this goes from -1, 1, 1, -1, 1, 0. Okay. So we shove this thing in there. Okay. And then our fragment shader gets this. The fact that like nothing's crashing is concerning me. If I like if I just do this, I just want to make sure that we do see like some sort of fuck behavior, which we don't, which is like a real indication that like something's not working right. Right? Like something's wrong. This was made literally right now. So am I like not disabling cache? Now it's just fucking broken? Oh, I'm running from the wrong directory now? Okay, refresh. Console. Like, why the fuck is my texture program not failing to compile? Right? Like, oh, because I'm using the wrong source. That would do it. That would do it. Ah, sick. Okay, so now there's a syntax error. Now everything is working the way I expect. I expect it to fucking break. Now we can... Oh, I actually didn't expect it to break. I fucking lied. What was it complaining about? 08 vec2 syntax error. I don't know what's wrong because I copied this directly. It could be that like the shader version here, like 300 ES, might have like some sort of like fucked syntax here. Okay, let's comment this out for a second. Well, we're gonna slowly bisect because I'm stupid. Okay, we'll start here. Comma on line 7, someone's saying. Comma on line 7. Oh, yep, that does look wrong, huh? Good eye. Now he's mad about a bracket somewhere. No trailing comma allowed. Yep, you're right. So I probably swapped order or something and just wasn't thinking. Equals assigned to non-constant to const high p 2-component vector of float. So I assume that this is line 12 here. This needs to be like this probably. Oh, I actually don't even need that, actually. That whole line is like not used. Oh, big green thing. Hello, did the string table PR work great? Yeah, it worked great. Thank you. Okay, big green is now available to us, which means that we should be able to draw whatever the fuck we want in there now. Whatever the fuck we want. Is this a park? Yeah. It's a really big green park. Okay. So now let's think about this. What actually do we want to do here? Let's start with texturing it with the data we have. I think that's the nicest first step. So we're gonna go into our fragment shader, and now we're gonna make a new fragment shader. We don't like this one anymore. It's going to be a set like image fragment. Okay, and he's gonna start looking like this, but we're gonna have to change him a little bit. But let's start by, so we don't get into that same state we were in a second ago. Let's start by fucking this up and making sure it gets fucked up. That's a big win. When it's fucked, it's fucked. When it's fucked up, it's the real me. Shut the fuck up. image frag pointer and image frag len. Here we go. And then we'll have image frag mint. He doesn't like that. Redeclaration of source. This is image frag. Okay, ASDF syntax error, which is great for us. And we're chilling again. Yeah, we're chilling. On mouse move, it clears itself because it's only in the initial render function. But we'll, one day we'll fix that. One day. Okay. So next up is trying to bind a texture, which I don't know how to do. But we will copy this. So we need to load the function somehow, which we actually haven't done yet. Let's start there. Before we have a thing to texture, we need the thing to texture, So we will just kind of unconditionally grab that image data off rip. So for now, image data is like const u8. I don't know if this is how we want to do it. Let's pull in stb image. stb image. We will start here next. So Yoinky's this guy. We make der dep, I guess. Der dep. Where do I want this? Source? Sure. Fuck it. Okay, so we have stb image, and we want stb image.c, and this is going to include stb image h, and define something, lowercase, define. It's image implementation, like this. And we also need to define the malloc and free calls. We need to ask it not to use standard library, which is possible. I just can't remember. Stabi no stio. That was words. So no standard input output. Standard lib will get included. So we need to link the standard library, but we can choose to this. It will only reuse headers. So I think it's fine. Can we define malloc and free? Yeah. So define stbi malloc if, and then we need free and realloc. And these are going to, we need to make these symbols somehow. Which I guess we'll define as a wasm. I guess we can just provide the C versions of these. That's fine, actually. It's not the end of the world. Okay. Then what? We need to get this shit into our wasm module somehow. So build zig, our wasm app is going to be wasm add source file, which is going to come from source equal to, nope. I can't remember. Add C source file. The C source file comes from file. stb image.c. Zig build wasm only, please. Only wasm, please. He's mad because we need to link libc now. Even though we're not actually linking libc. Finland Acri. Finn Ian. I can't tell if that's an I or an L. Finn Ian Darcy. Anyways, thanks for the sub. Appreciate it. Okay, so does this compile? This does compile, but it's probably not actually correct because we're not actually using stb image anywhere. So we kind of want to, maybe in our app zig, I guess is where I'll put it. Well, maybe say like const stb image is equal to c import. And then in here we c include stb image.h. He's probably going to get angry at us. No? Okay, okay. But he's going to get mad at us maybe as soon as we try to use him. So I guess even before we do this, we have to ask JavaScript to give us that shit. Which, sorry, I'm just thinking, how does that work? It has to be like super asynchronous. So we have to say to JavaScript, yo, bitch, could I have this image from this URL? JavaScript goes like, okay, I'll get it for you for a second. Give me 1 second. And he gets it. And then he gives it back to us. And he says, what? Like, okay, here's this thing that you asked for with some like ID of what of how you requested it. Okay, sure. That seems like it makes sense. But then like how do we know what we want to do with that? So I guess he says like, hey, you have this thing at this latitude and longitude that you know how to look up from your metadata. Like, fucking do what you want with it. Seems reasonable, seems reasonable. Can I dodge dealing with that for a second? Maybe not. Okay, sure. So what? Extern function fetch data. And I guess we'll like give him an ID of the data we're fetching, as well as like, maybe that's it. Oh, I guess we need to give him the data name as well. So like the like URL is going to be like a U8 pointer, and the len is URL len is a usize. So now we call like fetch data, and when he's done, he'll call back like data fetched, give us this ID back, which seems kind of reasonable to me. Okay. So we're gonna have like some function data fetched with an ID, and I guess we will do kind of like the same strategy where we say like push like runtime data, I guess we'll call it, and we'll also like push requested data. I feel like makes sense. So we say like, hey, could you get this for us, please? And we go like, okay, here you go. Then we have like requested data buff. We append the slice with the length, which is fine. Which means that here we need to store like requested data buff. And then here we have like global requested data buff. We like can like just kind of use this however we want. So for now, can we just say like render this and like feed this to the texture? So it's like, for now, let's just say that we have this thing. We'll kind of figure it out as we go. So this has like a std log debug fetched this ID size this, and then we will log the ID and the len. I think that's a good place to start. Seems like a good place to start. So now in the JavaScript side, we need to feed in this like fetch data callback. So fetch data is like a function that's kind of like going to be custom on our end. It's not like a path through to something else. So we'll call this like fetch data, and we bind ourselves into it so we have like stuff we can work with, and then we just look at our wasm handlers somewhere, and we need to say we have like a fetch data function. And he takes ID, and what was it? It was like a URLn. We kind of like yoink out the like thing from WebAssembly memory. So we say, hey, this is like a URL buff. Fuck me, fuck URL buff. And we look at this memory buffer, we look at the URL and the URLn. We have to turn this into something that we can work with. So we decode this stuff as UTF-8. Right? Like this. And then we fetch URL, and then we do something. So this is response. Can you like chain these things? Then like this, yeah, you can. So here we can say like, we get the response, and then we return response. I guess we say like load. We already have something that's like load data from server that has like a function callback that we call here. So maybe we abuse this existing function in some way. So it's like we load data from server, which is going to call push. What do we call it? Requested data? It was push requested data, yeah. So when we get some of this shit, we're good to go. And then once this is done, we don't even need to like know anything about what we got. We just say, hey, we can say that the data's there, baby. What's broken here? So this is good. We call this then, oh, we need this here. So then we just say data fetched. And we need to take the ID, which I hope that we can just kind of bind in like this and it's fine. I don't know how like the captures work here, if this is like fucked or something. Yeah. Once you're stuck in Vim, once you start Vim, you're stuck in Vim to the rest of it. It's awesome. People ask how to quit Vim. I answer you don't. It is true that like it just kind of ruined my ability to use stuff that doesn't have nice Vim bindings. It's kind of annoying, to be honest. Like it's so frustrating when I have to like write something in like a web browser and I just like fucking Control W to backspace and just close my fucking tab and I'm like, fuck, I should have seen this coming. I think mod is probably needs to be stored somewhere. Like here we don't. Yeah, do we not have access to call back into the thing here? I guess we don't, but we can just add that. That's fine. So wasm handler here, we instantiate the wasm module, and then here at the end we have to set that the handlers dot mod is equal to mod. And then here now we can call this dot mod and it's fine. But otherwise we would have had unbound data. Yeah, that seems reasonable to me. We probably should like actually like fix me queue requests. So right now, if we try to call fetch data more than once at a time, we're gonna like clobber our own data, which is gonna be a problem. But fuck it. Fuck it. Okay. So if now we should be able to just like in the render or like in our app init, let's look at the data that we got and just ask it to get the first satellite image. And just kind of see what happens. So we'll say this is the first thing that we want to fetch. And it comes from satellite metadata. How does this work? Satellite metadata. I guess this doesn't need to be by pointer like this because it's already like an array. And then we can come in and we say like satellite metadata at index 0 dot path. Fuck. This is actually wrong. This is fucked up because the path is like a path on my file system, not like a URL to a file that exists. So we need to fix that. We need to fix that. So like this needs to set this path to some like relative path relative to the file. So over here in our pre-processing, I guess like this shouldn't be resolved. We should not resolve this path. Then it should be relative to the current working directory where we ran the processing. And then what we have to do is when we're making the site, we have to basically iterate every single path in here and symlink that into our web directory. And then I think everything kind of works out, which is kind of fucking odd, but I think it's fine. We're probably in the wrong shell environment. So let's kind of get over here into the right one. And let's just kind of see what happens. Let's see what happens. Python. Test py. This is the one. Okay, cat output. So the output now has a relative path in path, which is very good. How long have I been using NixOS? Probably like a year or something. Don't really have a good answer. A while. But I've never really got too into it, to be honest. Like I'm like a little familiar with it, but like definitely my Nix knowledge is very low relative to the amount of time I've spent in it. I've like kind of intentionally not tried to learn too much because like I don't really care. I like the like idea of the like consistent OS, but I don't really like the like I don't want to like learn a Nix language that much. Like I just don't feel like it. But that will bite me in the ass forever. And you know, it is what it is. Where am I supposed to be over now? Now I'm in maps, and we want to change our make site to basically like when we get the satellite data, we want to like iterate every path in it and link that as well. So it's like we need to like open the file. So what? Open file. Args satellite data with I don't give a fuck arguments. We are going to, I guess, parse that stuff. So std JSON parse from token source, which means that we need a token source. How do I get one of those? Token source can be a JSON scanner with incomplete input or a JSON reader. Okay, so we create a reader given an allocator and satellite f.reader. And that's it. Does this fail? Nope. JSON reader is equal to this. And then here we are trying to read this into our satellite data. I can't remember what we called this. Yeah. So we're trying to read this into satellite data. And we pass in our JSON reader, allocator, JSON reader. Very likely this has to be variable and this has to be by reference, almost certainly, to be honest. And our parse options, I don't give a fuck. Then we'll call this data, satellite data. Defer satellite data deinit, I think. This probably has to be tried. And then we say for satellite data value, we have like an item. We look at the item path. No, he's confused. Why is he confused? Holy shit. Okay. Let's fuck these for a second. And that should reduce the amount of error spam that we have. Local value variable shadows. Make site 305. What? Oh. I see. Satellite data mod. That's annoying. But we'll live. We will live. Unused capture. Okay, that's like better. Way better. I'm digging the stream. I've dabbled with the ArcGIS but never gone too deep. Why is it listed as things that don't work? Last question, I promise. Oh, you can ask as many questions as you want. I can choose not to answer them if I don't want to. Yeah, sorry. Bad licensing. So I showed it at the very start of stream, but that was like 2 hours ago. I shouldn't say the very start. The very start of this portion of the stream. Specifically, like stuff like this, where they're like, "Hey, bitch, like you can't use this unless you use it with ERSI software." And I'm like, I'm not ERSI software. So they have like non-permissive licenses essentially. What is the renderer with red dots and port on the side? That is raw. We're raw dogging 2D HTML canvas context. So each WebAssembly module just writes out whatever pixels they want into their WebAssembly memory. We copy paste our WebAssembly memory into the 2D canvas context. You might ask, why the fuck are you talking about WebAssembly modules? So the way that this thing works is there's a bunch of chambers in here. Each one is defined by its own WebAssembly module. People can go and they can make their own WebAssembly modules and upload them to my site, and then I can like look at them and choose to accept them if I like them. So this like portal one wasn't written by me. This black hole one was not written by me. These were by like users in our chat that just wanted to have some fun and contribute. That is what is going on there. What was I doing? I was trying to look at the shit. So item path. So we want to look at every path. And we want to just like basically like patch it to work with well, they're relative paths, so it's fine. So as long as we copy the path into the right spot relative to the file we write out, it'll be fine. So we want to look at this path and we want to say, LMAO, you love to get distracted. We love distractions around here. So we look at the current working directory. And I guess it's like the output dir is something related to this. So thanks Roboto for linking spheroforia.dev. It's the upload page in there if anybody goes and looks, where it explains kind of all of like what goes on, how to make your own. What am I trying to do? It's like I want to like find the path relative to the folder that the satellite data is in. So I want like std fs path dir name of this, right? Satellite data dir. Then each of these paths is relative to this thing. So it's like std fs path join the satellite data dir data dir and item path. Okay, so this is the image path. The like input image path. And we just need to like link that shit into an output. So we need to make sure that like we need like an output image directory, probably. This probably needs like an allocator, almost certainly. And then why is my like indenting fucked? Something's confused. He's mismatched because I forgot a squiggly brace here. Hello. Hello. Defer input like alloc free this thing, I guess. So we have like an input image path. We want to create his output dir. So it's like output image path is going to be our output directory. Args output and item path. And the output image dir is going to be the dir name of output image path. Okay, we're getting somewhere. We have to make that directory. So std fs current working directory make path, which is the one that's like just fuck it, like do whatever you need to do. Okay. I think dir name returns a slice that is not allocated, which is fine. This has to be or else panic no dir. I don't really want to deal with this right now, so we'll just do this again. Or else panic no dir. This will get cleaned up in the future, but we are super fucking short on time. I want to get to the point where we are showing an image today, so we're gonna take a lot of shortcuts now in the immediate future. So this takes a slice, so this has to be like this. This has to be like this as well. Make open path will open the dir too. I think we don't need to open it. I think, but that is a good piece of information. Because I think now we just symlink the fucker. So let me think about this. We did this before because we need to get the relative outputs here. So it's like we need the input image path relative to the output image dir. Then we link that thing in output image dir. Is that where this goes? Or do I need to do output image path? I think I need output image path. Surely link path needs to be freed. This is mad about something. Probably because this needs to be tried. Both of these probably. All right. I'm like, maybe this will do something that I want it to do. It's not impossible. It's not impossible. Fuck! What's he mad about? Index zig. Expected this, found that. That's fair. That's fair. I did write an ampersand when I didn't have to. This should be like... That's fine. Fetch data expected 3 arguments found 2. What does this expect? ID, URL, and URL len. That's true. All right. Defer keyword is so that it runs something under current scope, right? Correct. I have missed, in fact, some defers right now. Where is this? This is the stack trace is not long enough, but we can probably take a guess. It's something about joining paths. It looks like. So here, we forgot this one. And this seems fine. These, I think the rest seems fine. We'll see. Nope, it's never fine. Pathword exists at symlink. So here we need to do the same thing where we delete the thing if it exists, which is a little annoying, but that's fine. This is a silly way to do it. We should probably do a link next to it and then move over or something, but whatever. So he is mad at JSON scanner. So I probably just didn't free the parse JSON file. Which is exactly what I did wrong. Now it's mad about... Whoa, I don't think I've seen this before. General protection exception. Did I double... Oh, I double freed. So I was doing before. So that wasn't it. I'm just a fucking dumbass. It's this one. We need to get the reader. I guess you read those phrases at the end of scope, but it makes it more obvious what was being freed. Yeah, and then also, like, I frequently will start writing error defers, even if there's no error thrown after, just because of the fact that, like, it's kind of protects you from future code changes, right? You're in a loop. Right now you know that, like, nobody's calling continue early, right? But in the future, someone might call continue, and it's easier to just not worry about it and like write the defer earlier than to like try to plan it out in advance. In C, like the overhead of like writing the go-to, I can like understand that that's like maybe a little too much, and like you'd rather just know. And also like arguably your blocks should be small enough where you're not struggling at that point. I kind of like, there's something nice about the manual memory management of Zig and the lack of shadowing. It kind of like forces you to write small scoped functions, or else you just like can't function, or at least I can't function, which is like actually kind of nice. There's something like I think underappreciated about that, where like the if it's some pain in the language, can actually force your code to be nicer, which is kind of nice. What's error defer? It's if you like raise an error. So there's like in Zig, there's like this concept of errors. They're kind of like errors as values, right? So you have like, you return basically a U16, but it knows it's an error, and so you can have blocks that run only if an error was returned versus if like a correct path was returned, which is nice. Using defer save there's a return at the end of scope 2. Yeah, exactly. Okay, so did we do the thing that we wanted to do? We were close. So he is linking to the wrong spot. Very clearly the wrong spot. So this is supposed to be the input image path, not the output image path. Oops, no, the link path is supposed to be the input image path. I'm missing something. I am missing something. He is going to output, which he shouldn't be. He should be going to input. So this is the satellite data dir, which is arg satellite data, given item path. I feel like this should not be what is getting written out. So there's just something fucking stupid happening here. So we got backup 1. So this is the correct input path. So why is this thing not linking to that? Is it because I fucked something up earlier and overwrite the input thing? No, this is like this is like a correctly just a file there. Okay, so the output image path, this is fine. Output image dir, also fine. So it's probably this that is kind of not working the way I expect. Do you mind using a software to show what keys you press on the keyboard? I wrote one at one point, and then I fucked it up. So like it required like input, like it required like some like permissions that I just never really set right, and then it was like kind of like a pain in the ass. I think this is backwards. So while I do appreciate that there is some niceness to it, it's like I don't really care enough to do it. There we go. That looks better. So now this is, in fact, I think linking to the right spot. Yep, chillin'. Big win for us, big win. And so now, did we heal? We didn't need to heal any paths because they're relative. So now I think that we should get this thing in WebAssembly land without changing any other code. I think. We will see, because I think that we wrote all of that stuff already. Refresh. Redeclaration of formal parameter URL at index.js136. Of course I fucked it up. Of course. We'll call this P and len. There. Fine. If you want to fucking be that way. Okay, so we did fetch a thing at index 0. We got it in Zig memory, and it is the right size. 201K is what we saw. So we are on the right path. Oh, 410, fuck. We are 10 minutes over normal, but I do want to get to the point where we at least show the image on screen. So I think I'm willing to go up till 5 o'clock, and if we don't make it by then, I will lose my mind. But I think we will make it by then, so I don't have to lose my mind. Okay, so we have the data. Now we just have to load it with stb image. So if we look at index zig, here we can, maybe we'll just say like global app load texture, which is a little silly, but you know, whatever, it's fine. And we'll pass in global requested data buff items, which is the buffer of data. And then we will write this function. We will write this function and we will discard ID because we don't actually use this, but this will later be used to tie stuff together. Okay, so what do we fucking load texture? I remember what we're doing. Pub function load texture. And this is the data. Okay. Now, what do? We're gonna, at the end of this, call self-render. But before that, we're gonna have to fucking bind some data, so. I guess before we get into ChatGPT telling me how to bind a texture, we actually need to like load the data. So stb image. This is gonna immediately start falling fucking over, but we'll get there. stb image.h. Load from memory. Okay, load stbi load from memory. We have data is equal to this. Okay. He needs a buff data pointer data len x y null 3. So we're asking for RGB data. And we do not care how much data there actually was. That's what this null is for. And so we need a width and height. Image width and image height. So our image width is an I32 equals 0. Image height is an I32 equals 0. And then we probably have to free this data. stbi image free data. Boom. Local constant data something something something. What's it complaining about? Shadows function parameter fine. Image data. Maybe we'll call it image. And this has to come from stb image as well. So this is gonna fail to compile because first of all, he can't find the header, so we need to fix that, which can be done in our build script. We say wasm add c include path of self b path source. Boom, easy. But he's also going to complain because malloc, free, and realloc are not defined, and they have to be. Well, first he's going to bitch about the int cast here. But then, there we go. Free, assert fail, realloc, and alloc. So we have to define those things. I guess we'll define them in index zig. I think is that probably where that makes the most sense. So this is size and returns a U8 pointer. Yep. We have free, which takes in a pointer and does something with it. We have realloc, which I can't remember what he does. He takes an input pointer and a size and returns a new pointer. And what was the other one? Assert fail. I don't know what the fucking API of this is. But we can probably just do like panic rutrow, right? If we don't if we have the wrong function arguments here, it actually doesn't matter, right? Because if he pushes 3 arguments onto the stack, and then we like don't clean them up, like who fucking cares? We panicked, right? Who gives a fuck? Who gives a fuck? Okay. Return null, which means that this probably has to be like an optional thing because we can return null on failure. And then this probably also has to be like a nullable thing. And we return null. Okay, does that build at least? It won't run, but it should build. Stir comp, stir, abs, pout, and load exp. Did we need all this last time? Maybe we did. Oh, we probably dodged some of these by limiting the number of, like, limiting which parsers we added. Yeah, we probably did. So maybe we will only support JPEGs. And maybe we can get away with less things. I think it's only... Let's try that. Let's try that. Much better. Signature mismatch. Defined as 4 I32s. Okay. Okay. I don't know what they are, but if you say so, these are probably like pointers and stuff. But you know, whatever. I've fucked up something. I32 comma this I32 comma this I32. There we go. Wow, okay. So it builds, and now what we have to do is like implement this stuff. So here we're gonna use like std wasm heap wasm allocator alloc, some u8s. We want to allocate them. We want like size plus 4, so that we can store like the size of this thing in the first 4 bytes. Okay, because we need the size to free. And then I think we also want to guarantee some alignment. I think that the malloc alignment is guaranteed to be like int alignment or something, right? Because like you call malloc and then you cast it to something, so it needs to know something. So let's just do a std like alloc with options, and we'll just make an optional alignment of 4 and null for sentinel value. I don't give a fuck about the sentinel terminated. Okay, so this is const ret. Ret from 0 to 4 is going to be a mem copy from real size. So stmem as bytes. Then we return ret plus 4. Simple. He's mad. Slice of non-array type because this has to be try. So this is catch return null in this case. Free now. We can call wasm allocator free, but we need to go from the pointer back by 4. So const real p is p minus 4. I don't think you're allowed to do point arithmetic here, so I think we need to do like pointer int from pointer p minus 4 pointer from int. Maybe? I don't know. Okay. This is nullable, so I guess we'll just assume that it's not. That's fine. So we say that the real p len is the first 4 bytes of real p. So 0 to 4. I think point arithmetic is fine. Not sure though. We'll try it. If you think so, I trust you. And you're gonna be like, no, don't trust me. I'm not sure. But you said not sure, so I will trust you anyways, and I will bite the bullet if I'm wrong. So this is going to be a u size, which is maybe like std mem bytes to value u size. I'll bite the bullet and then shoot you with it. Okay. We don't have to get like so fucking crazy out here. Okay. Let's see how this builds. He's mad somewhere. As bytes return type. Probably because as pipes needs us to do this. Okay, ret plus 4, incompatible types, this and comp time int. So I think we want like 4 onwards here. Expected this, found that, so maybe we write like end pointer. Yeah, okay, pointer arithmetic was fine. You were right. You were right. Nice. Then realloc is going to be something like this, but instead of freeing it, we realloc it. And the old mem is this, and the new size is size plus 4, which means that we kind of have to do like this stuff again. So it's like kind of like this, I guess. And then this is like real size equals size plus 4. I know you can't do stuff like pointer minus pointer. There's been some work happening recently on pointer subtraction. Good to know, good to know. Okay. Maybe. That compiles. I don't know if this will run, but we will see. So did we actually try to use this thing anywhere? Load texture, we did try to load this. So let's just kind of see like if we fucking crash. We might, but we might not. But I also don't know if it ran because we don't log anything. So let's std debug print hi mom, I'm on TV. He's mad because we don't have std debug print. We do have std log debug. Hi mom, I'm on TV. That's a good sign. So nothing crashed here, which means that it probably worked. Let's log the width and the height. Give him a sec. He's got to think a little bit. 1067 by 667. Let's see if that's right. 1067 by 667. 1067 by 667 at the top here. That's really good. Really good. Okay, so now all we have to do is shove this shit onto the GPU and load it from the fragment shader. So chat GPT webgl load image data into texture and sample from fragment shader. Can you show me, please? Help? Question mark. Dude, the fact that I can't believe that he answered this in like any sane way. This is like kind of what I want. So, okay, I don't give a shit about this. I just want to see like the texture binding stuff here. Okay, texture binding. He creates a texture, he binds it. These, I always forget to write these. Don't trust it, brother. Oh no, I know. Like, don't worry. I never like use ChatGPT and then say, bitch, I trust you. But it's like more like I'm just trying to like I've done this before. I just can't remember it exactly. So, and this is also something that should be common enough on the internet that he knows what I'm doing, what I want. So I'm pretty sure this is right, but we will see. Have you checked Claude at all? Nope. Nope. And then what's the other thing that we have to do? We need to like use it in the shader. So in the fragment shader, he creates a sampler. He pulls the UV, which means that we need the UV to come in from our side, from the vertex shader. Okay, sure. So let's start with. Are you not using the meme model? It's dumb as rocks. It is dumb as rocks, and maybe this is why I think that AI is shit. That's very likely. Okay. I think that we'll just kind of set this up in one giant run for now. We might want more flexibility on the textures later, but for now we can just kind of shove it all in one go. We do know that this texture thing is probably going to return some sort of OpenGL object. So we're going to return what is it? GL objects push texture so that we get like an nice little i32 out of it. We're going to assume that this stuff is right. Here, we need to get the data. So here we're going to say, hey, I have this like pointer in len. And we are going to yoink this shit from WebAssembly memory. This comes from this, and it is the pointer and the len. He's saying that he's expecting RGBA. I think that we have RGB. Stabby, thanks for the prime. Appreciate it. Yo, yo, yo. Yo, yo, yo. What's up? What's up? What's up? Welcome back. It's so fucking stupid. Image. Sure. And he gets bound here. So even though we should add a separate bind texture, shut the fuck up, we will just not. And what if I don't want any mip maps? I guess it's fine. Whatever, it's fine. Okay, now we need to like work with the uniform in some way. So fragment image fragment. Fuck your RGB, and instead we will work with this. We need some sort of like input, which I think is in vec2. Pause here. Then we need to sample. So I guess we just say out color is texture 2D. Is that what it is? Texture 2D. Pause X, pause Y. Fuck it. Sure. Then in the rect GLSL, we need to say out vec2 pause, and then pause equal to verts GL vertex ID. And then all we need to do is bind the texture, I think. Let's just see what happens if I build this and run it as is. It's probably like fucked in all sorts of ways, but file not found. Why? Because I'm in the wrong folder. As always. Refresh. So here he's mad. Texture 2D, no overloaded function found. Oh my god. GLSL 300. GLSL 300, yes. I just want him to give me shaders with the correct. Oh my god, work harder, work faster. Here we go. Texture. I will fucking say, that's really fucking sick. Just for the record, that I can just say this and he'll give me like the correct this. Like that's really fucking sick. I mean, maybe it's not correct. We don't know yet, but it's pretty fucking sick. Image fragment. So this should be texture. That's what he's saying, which is fair. We got this right, which is kind of nice. Refresh. Dimension mismatch, texture, no matching overloaded function found. Frag color, out vec4, frag color, out vec4, out color, texture. It does seem like it's still not right, to be honest. What did it complain about? We've been seeing some stuff about Zig, don't know a little about it. What sets apart from other modern low-level languages? I'll say that I do believe that Zig is not, it's good, right? It works really well. It's a lot like new C, right? But I think there have been a lot of attempts at new C. So there's something about Zig that I don't fully understand that sets it apart from all of those other ones. I mean, it's the first one that I've tried, right? And there's a reason for that, but I don't know what it is. But I do know that when I tried it and use it, it's very nice. So, take from that what you will. But it feels like it's, build system for starters. Oh yeah, when I was saying this the other day with Christoph in the chat, he was saying that like they've been pushing the build system as like a way in. So they wrote this build system that like works really well for cross-compiling Zig stuff, and then that happens to be very useful for existing C projects. So there might be something there. I don't really know, but I just like, so I can't tell you what sets it apart really because I haven't tried all of the other ones, but I can say that using Zig is very nice. C3 is looking good. Somebody's been watching a soding stream, huh? Like, someone's been seeing. Someone's been watching a TS Oding VOD. We can tell because when else would you have heard about this? Okay, did that build? I can't remember. It does look like this built and ran. So now all we have to do is bind the fucking thing. All we have to do is bind the fucking thing. So what is it? Like GL bind texture webgl bind texture. No, I want like uniform. Where's ChatGPT? What is he What are you doing over here, baby? Where is your U texture? Somewhere he looks for U texture. Get uniform location. Okay, cool. Cool. And then he must use that somewhere. Texture location. Whatever happened to carbon? Yeah, that's a good question. I guess it just immediately died. So this is an integer. So he binds texture, he activates a texture. Right, okay. Right. So here in app zig, we probably have to like how do we want to do this? How do we want to do this? I guess we'll just kind of do all of this here. Fuck it. We're not really too crazy. We're not worried about like actually doing the right thing here. We are just worried about doing something at all for some proof so we can end stream, right? Because all we're trying to do is get a picture so that we can end the stream. That's the goal. We're going to be fucking immediately transparent about it. So here we are going to use renderer GL. What is it? Renderer GL texture here. It doesn't exist yet, but we'll find it. We have to GUI active texture this thing. We need to GUI bind texture this thing, which comes from renderer GL, and we need to get the texture. So here we have like, I think we already have the texture bound from setup texture because we were fucking lazy. So let's get in here and make our GUI bindings this thing. Pub extern function, setup texture. So set up, the fuck did I write over here? GL is not supposed to be passed in here because we have this.gl everywhere. So here we have GL, this.gl, this.gl. GL dot is replaced with this.gl dot. Okay, oops, I missed some. Okay, so now we can go back to our GUI bindings and we just have a pointer, which is a const u8 and a length, which is a usize. He gets kind of like slapped down like this. Expected return direction, so he returns, I guess, an I32, which is the texture ID. So we call setup texture with our image pointer. Ooh. Interesting. Image width times image height. Is there not a stride with STB image? I guess not. I guess it's just width because we don't have stride anywhere. So that's fine. That is fine. We activate the texture. I think that in index.js we did bind the texture and it should stay bound. So we don't have to worry about binding this thing. We need to get the uniform of the texture location and set it to 0. So I think we have uniform 1f. We do need uniform 1i. So this is going to replace some of these things with an I. And now we are going to say like GUI get GL get uniform location of, I can't remember, it was like U texture, I think we called it. From the program. From the program, right? Yeah. So here we have our GUI texture program. No, renderer texture program. There we go. Now we can call GUI GL uniform 1i with the, I guess it's like lock. Okay. Seems chill. so far. He's mad because he expects an U size, so we'll just kind of int cast this. Value I32 is not ignored, so const text is equal to this. But we don't really need to do anything with it, so this is like this. This should be GL active texture. So we need to create that binding. Which is going to be like somewhere over here. So one eye goes to one eye, and then GL active texture goes to GL active. This is probably just like wasm handlers GL active texture, like this or something. I don't fucking know, man. Why is this broken? Expected comma. Am I fucking high? Oh, no, I don't see what's wrong here. Oh, I forgot dot. 3 dots, not 2 dots. And this would be argza, plural. 2 dots. That sounds like a thing that I've heard. I can't replace where. Oh, whatever. Whatever. GL active texture. Okay, so now we probably need to create this binding, which active texture webgl. Active texture. So we just take in the texture object. So here our GL active texture. I think we just need to get the texture 0 parameter probably. So we go here and we click for texture 0. Pub const texture 0 equal this. We are fucking getting close, I feel like. I feel it in my bones. GUI bindings needs a GL active texture who takes in a I32. And then we also need like uniform 1i, which takes in value as an I32. Okay. I feel like we're close. Expected 3 arguments here. What does he expect? Program name and name length. That's true. This is U texture. He needs U name pointer and name len. I feel like we're getting there. Link error. Setup texture is not a function. That is true. Setup texture goes to wasm handlers setup texture. Bind wasm handlers. Okay. Okay. Refresh. Mama TV. Argument 6 is not valid for any of the 6 argument overloads in setup texture. 119. Argument 6 is an image. He does not like uint8 array for some fucking reason. What does he want? 0, 1, 2, 3, 4, 5. Whoa. What the fuck is he complaining about? GL text image 2D. What are we doing here? What are we doing here? So it's 1, 2, 3, 4, 5, 6, 7. Whoa, 1, 2. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9? I guess we probably copied it from version 1 from ChatGPT. Let's copy it from version 2. 1, 2, 3, 4, 5, 6. Okay, something fucking wrong. 1, 2, 3, 4, 5, 6. It must be this. It must be backwards compatible. So the WebGL2 definitions must have the WebGL1 definitions inside them. The target level, internal format, type, pixels. And he's saying, what's he bitching about? This guy is like a little whiner. He's saying argument 6 is not valid for any of the 6 argument overloads. One, two, three, four, five, six. So he must be talking about image. So what are my allowed values for pixels here? Pixels. The following text can be used as a pixel source when width, height, and border are specified. I see. Okay. So here, I guess we need width, height coming in here. And then text image 2D, we use an overload that takes width, height, border here. So this is after internal format. So this is RGB, then width, height, border 0. Then we have format type source. So now we should be able to use this, but we need to pass in now on setup texture in GUI bindings. This needs width, usize, height, usize. It's fine. It's fine. It's fine. It's fine. It's fine. So now we pass in image, width, image, height. Okay, 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 and fuck it. We'll make them I32 so I don't have to worry about incasting. GL RGB twice. Once is like the format of the data we're passing in, and once is the format of the data in the texture on the GPU. Which is confusing for sure. Desired upload requires more than are available. Fuck! Okay, okay, it's fine. It's fine. It's fine. It's fine. Okay, it's fine. Guys, everyone chill. Everyone chill. Everyone else who's not chill needs to chill. Convert this to, okay, remove the symlink. We convert this to this, and we resize to 10% again. Fuck! Take a deep breath. No! No deep breaths. Only stress. Even though I told you to calm down, I am still not gonna calm down. Fuck! Okay. So just take this guy and put... okay. That didn't fucking do jack shit. Because I didn't fucking type resize like a fucking dumbass. Okay. How's this look? Really fucking low res? Way too low res? But I don't give a shit, okay? Okay? I just want to see fucking something, okay? Oh. Desired upload requires more bytes than available. Oh, wait, maybe it's not about the amount of memory that we're using, but because the error is like the same ratio. It's that the we need to specify the correct data type, probably. So what did, I actually don't know, what the fuck did stb image give us? So let's look at stb image.h. I think that it might just be easier to ask it to give us RGBA. Where does it talk about like channels? stb image load. Load from memory. Here we go. Okay, so somewhere they're going to tell us about the desired channels thing. If desired channels is num0, blah, 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 blah. So the output and end components have the following pixels interleaved in this order. RGB. Okay, so it's 3 bytes. 3 bytes. So I don't really, okay, let's look at the texture. Oh, when we pass in the length, we use image width times image height, and we need to multiply this by 3 for RGB. Everything else I think can stay the same. Okay, this is a lot closer. 21705, 21507. Now that's confusing. That is confusing. Index.js. Where the fuck is my fucking editor that is complaining? Oh, it's probably out of one shot. Here we go. Okay. So he's complaining that the desired upload requires more bytes than are available. So why is that? Okay. Console log width height, width times height, width times height times 3. And then len. We'll look at all of these things and we'll see if we're like doing something just like fucking brain dead fucking stupid. So where is this 21705 coming from? Desired upload requires more bytes than are available. So our width times height is 21507, which is what we're seeing over here. 21705 is fucking confusing. Confusing. So this is coming from text image 2D. Text image 2D. I mean, we should just double check, I guess, that we got this stuff in the right order. Target, level, internal format. Internal format, RGB, width, height, border, type. Is type the right thing here? Oh. Am I not supposed to write? Wait, format, type, source data. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it format, type? Do I have those flipped? Format is internal format. Then type is unsigned byte. Okay. 8 bits per channel for RGBA. Oh, maybe my internal format can still be RGBA. It's the input format that's RGB. I wonder if that's like, that shouldn't make a difference, but internal format must match unpack format. Okay. I'm just really confused about this. This is really because like the amount that it's off is this like confused, like the amount that it's off is like very strange to me. Isn't this the classic GL texture limitation? They depend on the backend, I believe. I don't think so. Okay, what if we do RGBA and RGBA? Let's just kind of see how that changes things. We need to change something because we're clearly fucking stupid, right? We clearly need to do something. Pack alignment, that does sound maybe right. Although I would think that the input alignment doesn't matter. But maybe it does. So we'll ask for 4 channels and we'll multiply by 4 here. This will need to be discarded, by the way. I don't know why that was. Oh, it does need to be discarded. I'm a fucking liar. Why is it complaining? Probably because it's just fucking broken. Let's fucking go, baby! Let's fucking go. So I think that probably RCR Nistin is probably right about the pack alignment. And I bet that with just like 4 byte with like RGBA, it's probably fine. Okay. Sick. I'm really happy with that. That's good enough for me. We have an image. It's on the screen. It's not perfect. It's not in the right spot, but it's there. And fuck it. Let's call it for today. We'll be back tomorrow to finish this stuff up. So there's still a lot more work to do, right? We still have like positioning it correctly in the world, kind of like tying it to the position of the viewport. We have like level of detail stuff to do. I'm pretty sure the image is flipped from what it's supposed to be. So we did go around an hour over, but I am happy because we now have, this is actually like pretty, there's a lot of pieces that went into this, right? Right, we like converted some data from Mr. Sid from Vancouver Open Data. We figured out how to like request some data from Zig in like, we request that JavaScript fetches some data from the server back into JavaScript, and then it gets pushed into Zig and then like fed into this other callback. That's pretty great. That's like a lot of stuff to think about, as well as like the structuring of the data, where like the metadata that we get after processing the Vancouver data has like relative files. Those all have to get like into the right spot in the web directory. So it was like a lot of stuff. But it does. I was hoping that we get farther, but that's okay. You know, I had some fun stuff anyways. Fun stream. Thanks, Greg. That's right, because for those of you on YouTube, we got raided by Prime earlier, and everybody in the stream thought my name was Greg for some fucking reason. I don't know why, but now I guess everyone's gonna call me Greg, and they won't know my name, and I'll have to live with it. Yeah. Okay. Thanks, guys. If you like what you saw, we stream most days at around 12:30 Pacific time for around 4 hours. If you're watching on YouTube, what you're seeing in YouTube is what we were calling main course, which is served after happy hour. Happy hour is from like 12:30 to 2 Pacific time, where we kind of like if we look at like the state of the code right now, shit, right? Just like absolute hot garbage, right? And so happy hour is kind of about like less about like feature development and more about like trying to take this shit storm and turn it into something like usable and committable. So that happens. If you want to check out the YouTube, there are links, or there are like playlists for each of the projects we're working on. Right now we're working on this map, but you know, there's other stuff in here. There's like an operating system and a terminal emulator and a QR code decoder and like a video editor. There's stuff in there if you want to go check that out. If you want to throw money at me, you could throw money at me on all three of Twitch, Patreon, and YouTube. If you want to see the code associated with this project, it is on GitHub, which is linked in the Twitch description. If you want to submit a chamber to the little animation on the right side, you can go to sphereforia.dev. Check out this like upload page. It kind of explains like the memory model of like the WebAssembly stuff and like how you're supposed to like draw stuff and do physics and stuff. So if you want to check that out, we would love to have your submissions. I think that's everything we have to plug. Twitch, let's find someone to raid, and YouTube, let's say goodbye. Bye, YouTube.